Hi everybody, it's Mr. Garrett here, and we're going to go over parts of 6.1, which is talking about rational functions and putting them in exponent notation and radical notation. So the first thing we're going to do is we're going to go through and talk about what it really means, or what we're going to use radical functions for. And normally if I give you something that looks like this, x squared equals 4, what you're going to do is you're going to go ahead and square root both sides. To undo a square, we square root it. And so the square root of x squared is x. The square root of 4 is 2. Now, because we're solving an equation, we could do plus or minus 2, because 2 squared is 4 and negative 2 squared is 4. However, if I were just asking you to evaluate the square root of 4, you would just say that it's 2, because that's what we get when we square root or even root a positive number. Now, when we go ahead, we can do other values, such as the cube root of 8. Cube root of 8 is 2, because 2 cubed is 8. We could do the fourth root of 16, and that will also be 2, because 2 to the fourth is 16. And so this is root functions or radical functions that we're going to work with. And in reality, or what we're going to actually use them for, is like if we have the nth root of a, we can rewrite it as a to the 1 over n, and that will help us evaluate these. This is called radical notation, and this is called exponential notation or exponent notation. So today what you're going to be asked to do is go and convert from radical to exponent notation and exponent to radical notation and back and forth, and then evaluate some of these. So let's go through a couple of examples. First example we're going to have is the square root of 7. Now there is no number right here, and when there's no number there, we assume that it's a 2. And so what we're going to do is we're going to say, oh, well, that's 7 to the 1/2 power. Okay? If I have the cube root of 8, that's going to be 8 to the 1/3 power, because there's my root, my n value, and so it's 1 over n. If I had the 7th root of 243, that would be just 243 to the 1/7. So here we have radical notation, and then we're converting it over to exponent notation. All right, now let's do exponent notation to radical notation. If I have 5 to the 1/3, that means that I'm going to take the cube root of 5. If I have 7 to the 1/2 power, we already did this one, all right, that's going to be the square root of 7. I don't have to include the 2 right here, because it's understood that if there's no number there, it's a square root. And then let's do one more. Let's do 16 to the 1/8 power. That's going to be the 8th root of 16. Now, we're going to get into trying to evaluate some of these values, some of these expressions, and it's very important that we know our perfect squares, perfect cubes, perfect fourths, and even perfect fifths. So let's just write these out real quickly. Perfect squares. We got 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared 25, 6 squared is 36, 7 squared is 49, 8 squared 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and then 14 squared is 196, and 15 squared is 225. So there's our list of perfect squares, from 1 squared all the way down to 15 squared. We also need to know our perfect cubes, and our perfect cubes go like this. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Should have all 5 of these memorized. And then from there we can also go 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. We could also go on and do our perfect fourths, which would be 1, 16, 81, 256, and 625. And even our perfect fifths. Our perfect fifths go 1, 32, 243, 1024, and 3125. It's not so much that you have these memorized, it's just that you can recognize them and then be able to figure them out. Now the reason that's going to be helpful is because when I ask you to do the square root of 81, you should quickly and easily tell me that it's 9, because 9 squared is 81. If I ask you to do the cube root of 64, you should know that 4 cubed is 64, so the cube root of 64 is 4. You should also be able to do that negative 27 to the 1/3 is asking for the cube root of negative 27. And in order to get that, we're going to say negative 3 cubed is negative 27, because 3 cubed is 27. Negative 3 cubed has to be negative 27. Okay, you're going to talk in a second. All right. And then the last thing is we want to do some of this stuff on our calculator. And so if you pull up your calculator, on the Inspire right here, if you press Control and the caret button, it'll give you a value here where you can plug in the root, excuse you, and put in the cube root, cube root of 27, and press enter, and it'll tell you it's 3. We can do the square root by doing second or Control X squared, and then just typing in 16, and there's our value. Now sometimes it's going to give us some decimal answers. For example, the 4th root of, let's do 25. That gives me a decimal answer because this is an irrational number. It's going to go on forever. Now, I had a little help making this video. Grace is feeling a little sick today, so I got to stay home with her, and she wanted to say hi to everybody, so say hi, Grace.
Hi.
And show them your calculator that you've been working on. She's got the TI-nspire here, so she's been plugging away and helping me color some stuff in our video. So, do you have anything you want to say? No?
Yes.
Yes? What are you going to say?
Judy.
No. Say good luck and hope you guys learned a lot. Bye-bye. Bye-bye.